Hello, the Humble Math Tutor is here to bring you the Fraction Exponents Starter Pack. Before we begin, please remember there are 7 power rules. Here they are here. Feel free to take a screenshot of them if you like. A good use of your time is to practice writing them out until you can do it from memory. Alright, let's get started on the fraction exponents. That would be with respect to power rules 6 and 7. Just getting my page square. Consider this quantity, 8 to the 1/3. What could that possibly be? It looks kind of baffling, really. But let's pretend we had 8 to the 1/3 and we multiplied it by 8 to the 1/3 and multiplied it again by 8 to the 1/3. By power rule number 1, that is adding the exponents when you're multiplying powers of like base, a third plus a third plus a third would be 8 to the 1. Which means whatever this quantity is, you're multiplying it by itself 3 times to give 8. Well, there's only one number that does that, and that's 2. That means 8 to the 1/3 must be 2. I wonder if we could attach meaning to that. Well, 2 is the definition of the cube root of 8. So we could say the cube root of 8 times the cube root of 8 times the cube root of 8 equals 8. So if you compare these 3 equations, we can say these quantities are all the same. So it suggests that 8 to the 1/3 equals the cube root of 8. If you need any more evidence, you could consider this. If you took 8 to the 1/3, which we suspect is the cube root of 8, and you cubed it, that would give you, now you're supposed to use your power rules for this, right? Remember power rule 3? If you have an exponent to an exponent, power to an exponent, you multiply the exponents. So that's what we're going to do here. If you multiply these numbers, a third times 3, that just gives you 8 to the 3/3, which is 8 to the 1. So it is true that if you cube the cube root, you should get the original number back, so that seems to stand up to scrutiny. So this is enough evidence for mathematicians to say, why don't we define the a to the 1/n to be the nth root of a, so that the fraction exponents behave in a consistent fashion with all other power rules. And that is your 6th power rule. Let's practice it in a few questions. Suppose we were asked to evaluate, without a calculator, 25 to the 1/2. Well, what we do is we would view this as the left-hand side of our 6th power rule, where n is 2, and we'd say that will be the square root of 25, which of course is 5. Another example would be negative 27 to the 1/3. The negative sign is not a cause for concern. The question works out just fine. So viewing this as the left-hand side of our rule, this would be the cube root of negative 27. So you have to think, what number times itself 3 times gives negative 27? That's what's going on here. What number times itself 3 times gives negative 27? Well, that would be negative 3 times negative 3 times negative 3. And this is best done in your head, trial and error. Don't reach for the calculator unless you have to. And that would be negative 3. Another example would be 625, yep, a 3-digit number, to the 1/4. Again, view this as the left side of our power rule, and you would have the 4th root of 625. Use familiar number patterns, right? Like, 5 squared is 25, 5 cubed is 125. You even know 25 times 25 is 625, so it doesn't take much playing around to figure out that a number times itself 4 times to give 625 would be 5 times 5 times 5 times 5. So that would be 5 there. All right, let's try one with a fraction. So let's try this one. 4/9 to the 1/2. Again, because it's a fraction, it's not a cause for concern. We can still be very successful with the question. You view the 4/9 the same way you view a here. You just put the 4/9 in where a was. And whatever n is goes in the nook of the little radical symbol. So then you would have the square root of 4/9. Notice I made sure the radical symbol covered all of 4/9. So then you think to yourself, what number times itself gives 4/9? So you have to think, what fraction times itself gives 4/9? Well, you can split it and do the numerator and denominator separately, and it will be 2/3 times 2/3. Right? 2 times 2 is 4, 3 times 3 is 9. So that would give you 2/3. Very good. A good exercise to do is to work on, to practice and get yourself very proficient and quick with these. A good exercise to do is to list out the set of squares and the set of cubes. By that I mean, see how many perfect squares you can memorize. So that's set notation, those parentheses. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. See how high you can go, and so that all these numbers are familiar to you. See how high you can go. Okay. I would suggest you go up to 30 squared, which is 900, right? If you can get that high and memorize all the perfect squares up to 900, that would be great. And another thing is very good for you to do is to write down and practice recalling and recognizing the set of cubes. So you recall the set so you can recognize different perfect cubes when you see them. So if I wrote out the set of cubes, I'd have 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, and so on. Up to 10 cubed would be wise if you could get it that far. And then you're familiar with these numbers. When you see them, they're like little red flags for you. You need to know them for this topic. All right, let's continue on with Power Rule 7. What do we make of this when we're doing Power Rule 7? A to the m over n. Now we don't have a 1 in the numerator, we have an m. What should we do with that? Well, this can be written using Power Rule 3 as a to the 1 over n all to the m. Remember, if you have a power to a new exponent, you can multiply these exponents. That was Power Rule 3. So if you multiply m times 1 over n, you get this back. Now, no one says you have to do it in this order. You could also do it in this order. A to the m to the 1 over n. Now we know what this is because we just did it. It's Power Rule 6. So that would give us a to the m over n is, and this is going to be the nth root of a all to the m, which can also be written this way, the nth root of a to the m. I recommend you use this version. I think this keeps the numbers a little smaller, but it's correct whichever version you choose to use. Let's do some practice questions using this Power Rule number 7. So a good one to start with would be evaluate 8 to the 2/3. Well, remember how it goes, eh? That's the numerator, that's the denominator. So the 2 goes where the m was, and the 3 goes where the n was. So this would become the cube root of 8 quantity squared. Strictly speaking, the brackets aren't necessary, but it does help divide the processes and keep them separate. So the cube root of 8 is 2. So that command has been executed. This command has not been executed, so it's still there. So the brackets are replaced by the 2. And 2 squared is, of course, 4. So that's right. 8 to the 2/3 is 4. Let's try another question. How about 16 to the 3/4? 16 to the 3/4. So applying the same rule the same way, correct? We're up here. Apply the rule so that the 3 behaves as does the m and the 4 is like the n. Drop everything into position. So this would be the 4th root of 16 all cubed. So you have to think, what number times itself 4 times gives 16, right? Something times something times something times something gives 16. What multiplies to 16? Don't reach for the calculator. Try low numbers in your head and you'll get it before long. 3 times 3 is 9, times 3 is 27. Oops, that's too big. It can't be 3. Let's try a smaller number. 2 times 2 is 4, times 2 is 8, times 2 is 16. Bingo, that's the number. This must be 2 cubed. Again, the 4 has been executed, that command, the 4th root, but the cubing hasn't been done yet. 2 cubed is going to be 2 times 2 times 2, which is 8. Very good. Let's try one with a negative exponent. Let me write this question down. 9 to the minus 5 over 2. Now remember what the negative exponents are doing. Remember what they represent. We have our power rules here. We can refer to them anytime. The negative exponent is power rule 5. So if you have a negative exponent, you write it as 1 over the positive exponent version of that power. So that's the first thing we'll do before we deal with the fraction exponents. We'll deal with that. So this would become 1 divided by 9 to the positive 5 over 2. Now we apply our 7th power rule. So that would become 1 over the square root of 9 all to the 5th. And then you'd get the square root of 9 is 3. So you'd execute that first and leave this guy for a minute. And you'd have to multiply 3 times 3 times 3 times 3 5 times, wouldn't you? Right? You may wish to take a moment and write that as 3 times 3 times 3 times 3 times 3, just to stop and catch your breath and think about it. And then you've got to multiply that out, right? 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 again is 243. So then your final answer on that one would be 1 over 243. If you enjoyed this video, please like, subscribe, and share. If you have suggestions for topics you'd like to see in future videos, please post those ideas in the comments below. Thank you.